All right, thank you for watching. So you're getting into parabolas. If you haven't watched the first video, please go back and take a look at it. The plan is for this video, for the second video, is to take a look at the two different types of parabolas. The first one being vertical, followed by horizontal, and looking at how the equation relates to the actual structure of the parabola and how we're going to use the equation to graph the parabolas. The first thing is we're going to take a look at the vertical parabolas. Now, the standard equation of a vertical parabola is going to be x minus h squared is equal to 4p times the quantity y minus k. Some of the things I'd like you guys to notice about this is that number one, the square is on the x variable. I know it looks like there's 4 or 5 variables here. There's actually only 2 variables, the x and the y. The h and the k are defined numbers that you're going to be looking for, and the p is also a defined number that we're going to have to find. So the only real variables are x's and y's, and this one, the x is being squared, which is very similar to the problems that we had back in chapter 2 when we were talking about parabolas and quadratics, where the x was being squared. So what I like to do is I like to think to myself, anytime we see the x being squared, it kind of reminds me of when it looks like this, when it looks like the parabola that's going up or down, because that's the types of functions we were graphing. And then when y is being squared, that's a different type of parabola. All right, so the first thing you're going to want to keep an eye out on is p. Find out what p is, and then find out what your vertex is. So first, find those two things. After that, there are 2 different scenarios. So we know that it's going to be a vertical parabola. What that means, it's either going up or down. Now, whether or not it's up or down is actually dependent upon the p. So what we're going to say is that if p is greater than 0, in other words, if p is positive, what we're going to get is a parabola that kind of looks like this guy right here. So that's what I'm going to start off. I'm going to start off when p is greater than 0, we get a parabola that looks like that. Next, what happens if p was less than 0? What if p was negative? Well, if p is less than 0, then what's going to happen is our parabola is going to be upside down like this. And those are the 2 different scenarios that we have. So the most important thing to understand here is that when p is positive, we make sure that the parabola is going to be going up, and when p is negative, the parabola is going to be going down. After you do that, you're everything is pretty much the same thing. The first thing is our vertex. Our vertex is right there. So that h comma k is going to tell us that our vertex, where its location is, and that essentially tells us how our parabola is going to be set up. So our vertex for this problem will be there. The same thing is true over here. This is going to be our vertex. Next, the focus of the parabola. Now your parabola is going to open up in the direction of your focus, and your focus is going to be over here, inside of the parabola. So I'm going to say that the focus is there. And you can say the same thing on this one. Instead of the focus being upward, the focus is inside the parabola. So over here, the focus is in the parabola. So the focus will still be in the parabola. It's just going to be right there. Next. Now, remember, the definition of a parabola is a set of points that are equidistant to both the focus and the directrix. So if the vertex was this many spaces away from the focus, then the directrix must also be that many spaces away from the vertex. And this is what's going to give us our directrix right here, and our directrix right here. Okay, now a lot of this you're like, okay, I get that, but what's the relationship between these? Like, how do you figure out how far the focus is? And this is where p comes into play. The distance between the focus and the vertex is p spaces, and the distance between the vertex and the directrix is also p spaces. So the distance between any vertex to its directrix is always going to be p. And the distance that the vertex is to the focus is always going to be p. Now, if we think about that, when p is positive, if we were to add the vertex to the focus, if we were to add p to the vertex, that would end up giving us our focus right here. So we're going to start off with first the information that we understand or that we have. We have our vertex. Our vertex will always be at h comma k in both of these scenarios. Now, to get to the focus, you'll notice that in this scenario, the focus is p spaces above the vertex, which means that our focus, we would have to add to move it up, which means we have to add to the k. So our focus is going to be h comma k plus p. Now, if p is positive, that'll push it up. And if p is negative, that'll push the focus down. So this equation, h comma k plus p to find the focus, will be used for both of these. Now, I'm not the type of student or type of teacher that actually uses these formulas, but I do write them down for individuals that find it very useful. So now you have these two points, h comma k, which is the vertex, and then h comma k plus p, which is going to be our focus. Now, next is the directrix. You'll notice that the directrix is a horizontal line. A horizontal line, so I'll write down directrix. A horizontal line is a line where it starts with y, so we're going to say y is equal to. And you'll notice over here we have to go p spaces below the vertex. So we're going to have to take that k and subtract p spaces from it. So this is going to give me k minus p, and that'll give me the line over here. Well, what would happen if the p was negative? Well, if you're going to go k minus negative number, it's actually going to be the same as k plus, and this is why the directrix gets pushed above the vertex. And this gives me my directrix. So now I have my directrix equation, so that's the equation for my directrix. I have my focus equation, so I have an equation that gives me the focus point, and then I have my vertex based upon the equation. There are two more points that I want to talk about. The last two are the endpoints of the latus rectum. That point there and that point there. Now, if you recall, if the distance between the focus and the directrix is 2p, then the distance between the focus and the latus rectum endpoints also has to be 2p. So what we're going to say here is that to get to the latus rectum, what you're going to want to use, so I'll call these guys LR1 and LR2, to get to lattice rectum endpoint 1 and the lattice rectum endpoint 2, you're going to want to take your focus and add 2 p's and subtract 2 p's to move left to right, which means adding or subtracting to the h. So our lattice rectum points, our first one is going to be at h plus 2p, comma, k plus p. Sorry, not kp, but k plus p. And then the second one is not to add to that, so not to add to get to this point, but to subtract to get to this point. This also works over here in this picture. If I was to add 2p, I'll get to this lattice rectum point, and if I was to subtract 2p, I'll get to this lattice rectum point. And this is why the lattice rectum points are at h plus 2p, comma, k plus p, and h minus 2p, comma, k plus p. And this is the basic understanding of how the vertical parabola is going to work. Be careful, this is only true for vertical parabolas, regardless of whether or not the p is positive or negative. So when I'm dealing with vertical parabolas, what you want to focus on is that the square is on the x, and that indicates that it's vertical, and then the p being positive tells us if it's opening upwards or if it's opening downwards when p is negative. After, remember, the focus is always going to be wrapped around, or the parabola will be wrapped around the focus, or the focus will be inside the parabola. The directrix will never cross the parabola, and then your lattice rectum will always be parallel to your directrix. Your directrix and your lattice rectum will always be parallel. All right, so now that we've taken a look at the vertical parabola, I'd like to go into the horizontal parabola. It's pretty much the same exact thing. The biggest difference is that you'll notice it's no longer x being squared, it's actually going to be the y component being squared. What this is going to do is it's going to give us two options here. We're either going to have a parabola that opens up positively, so it's going to open up to the right, or what we end up getting is a parabola that's going to open up to the left. And once again, it's going to follow under the same rules. The reason the parabola would open up to the right is because the p was positive. And the reason the parabola will open up to the left is because the p is negative. But after you get the p portion, you just want to make sure, or after you understand the p portion, you can start by graphing the vertex. Well, we know the vertex v will be right here, and in the other scenario, the vertex v will be right here. Now, if you recall, the focus is always inside the parabola, so I do know that the focus over here is going to occur, and the focus over here is going to occur, both inside of our parabolas. And then if I move outside of the parabola, I can draw the directrix over here. So now we have the directrix, and I can draw the directrix over here. Remembering that this, the vertex to the focus is a total of p spaces. And then the vertex to the directrix is also a total of p spaces, and this now can lead me to my equations. So my vertex I know is at h comma k, that point right there, but then I have to add p to the right. I have to add p to the x value to get the focus. So I'm going to say the focus is at h plus p comma k. Notice the difference. In the last problem, or in the vertical parabolas, the p was being added to the k because we wanted to move it up and down. But now because we want to move the vertex left and right to get to the focus, we're adding it to the x coordinate. So my focus is at h plus p. Now, what would happen if the p was negative? Well, instead of the focus moving to the right, if P was negative, the focus would move to the left. And it makes sense. So it's consistent with both scenarios, when P is positive or when P is negative. Followed by that, we can find our directrix. So our directrix, you'll notice, is now going to be a line that crosses the x-axis. So our directrix is going to be the equation x equals, and then we just have to move to the left by p spaces. So we're going to take the p and subtract it from our h. So we're going to say h minus p. Now, once again, if p was negative, that would mean double negative, and the p would move the directrix in the positive direction. All right, the last 2 points are the latus rectum points. So remember, the latus rectum has to go through the focus, but it also has to be parallel to the directrix. So the latus rectum point there and the latus rectum point there. The most important thing to remember about the latus rectum is that they're not p spaces away, but actually 2 p spaces away. So we have 2 latus rectum points. The first one, latus rectum 1, we're going to add 2p so that the focus gets pushed up 2 p spaces. So our LR1 and our LR2, lattice rectum endpoint 1, lattice rectum endpoint 2, is going to be from taking our focus, which is at h comma or h plus p comma, and pushing it 2 p spaces up on the y coordinate, so k plus 2p. And that one will give us the one above. But then, if I subtract it, h plus p, and then do k minus 2p, that'll give me the lattice rectum point below it. It'll also give me the points over here, even if the p's were upside down, or sorry, negative, it would, instead of giving me LR1, give me the one above, it'll give me the one below, and it doesn't really matter which one we call first or second. They just have to be the lattice rectum points. All right, go ahead and, if you don't understand this, go back, rewind it, take a look at it. If you want to see some example problems, please watch the next video. There are 2 types of problems. One where the equation is already in its format, and then you kind of have to graph it, and then one where you have the graph and you have to kind of explain what the equation is. The second type of problem is where it's not in its format and you have to reconstruct it to get it in its format. Thanks for watching.